Hey, Dr. Hines here. All right, so over here we've got our beaker. It's gently boiling, and what I'm going to do is I'm going to take this hot water, pour it into the hot water calorimeter because we need to know the temperature of the water of what we have in here. So I'm just going to grab it, dump it in here. Notice that perfect PhD rotation of the wrist right there. Put our lid and our thermometer right here. And what we want to do is we want to record what the temperature of this hot water is. And I'm hoping that you can see the increments on the thermometer okay. We'll try to rotate it so you get just enough of a number and some increments here. So what is the temperature of this hot water? That's what you're accomplishing right now. So we're just going to look at it, we're going to look at it, we're going to look at it, and at some point you're going to say, hey, this is what the temperature of it is. And then what we're going to end up doing is we're going to take the hot water and we're going to pour it into the cold water, and we're actually going to measure the temperature again. All right, so we're gonna do this here. And I need to do it kind of quick. I don't want this to start cooling down, and I need to get it over here fairly quick. So here we go. Oops, kind of stuck in the beaker there. I'm just gonna grab the whole thing, dump it in there, try to get this lid on here quickly, and hypothetically, I'll move this other beaker out of the way here. Right, I didn't lose any heat by how slow I poured it in there, right? We captured all the heat in here. Maybe we did, maybe we didn't. That's kind of why we're doing this part here. We know it's not going to be perfect, so we're going to assume whatever error we make will be a consistent error throughout the whole experiment. All right, so hot water was mixed with cold water. They need to equilibrate with each other. Okay, what does equilibrate mean? What is that going to look like on the thermometer? And when you're satisfied that the hot and cold water have equilibrated with each other, then that's the temperature we're going to record on the data sheet. Okay, so on the data sheet, let's see, there's a couple of numbers we're going to need to write down. So let's see what we got here. Temperature of the hot water. Yeah, we measured that. That was in the coffee cup with the hot water, so we got that recorded. And then we mixed the hot with the cold water, and wouldn't we call that lukewarm? Probably. It's all a matter of definition, but it equilibrated. It equilibrated to a temperature value, and you would record that right there. So I think there's only one piece of information that we need to collect, and then we're done with this side. Okay, the very last thing that we're going to record is we're going to record the mass of the calorimeter with the cold water and the hot water in it. So one more time, we're going to weigh the whole thing. It's got hot water and cold water in it. I'm going to tare it right quick. Okay, gonna put it on here, and now we need to record. We're gonna look at the electronic balance, think about what it's saying, and we're gonna record this on the data sheet. And hey, it's gonna fluctuate around on you. That's just, hey, that's real life right there. You're just gonna have to decide what you want to put that for that value. And down here, let's see, calorimeter, massive calorimeter, cold water and hot water, and that's where that piece of data is going to go right there. So we're done collecting all the data for this, and now what we're going to have to do is we're going to have to do some calculations to make sure that this data, I'll just say that the data looks good so you can continue on to part 2.